Alright, so this is an example where we are trying to add and subtract phases, right? So if this were to be, let's say, a DC circuit, and then we have a value for this one, for instance, the voltage here, and then we see the voltage is, let's say, about 2 volts, right? And this one is, let's say, about 6 volts, right? If we are trying to find, let's say, V1, if we are trying to find V1 plus V2, we just add them up, right? That's uh 2 volts plus 6 volts, and that gives us 8 volts, right? But then in AC, it's a whole new story, right? We don't add them that directly like this. Are we okay? So this is what we're trying to do. So if we are trying to add up V1 and V2, one thing that happens in AC is that we can only add up sinusoidal quantities that have the same frequency, right? So let's check something from this. We can only add up sinusoidal quantities that have the same frequency, right? So if you look at this one, for instance, within this particular period, right? So this period, the period is 1 cycle from here to here, right? So this one has let's see how many cycles within that one period. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3. We can't add them directly because what their frequencies are different, right? So that's the principle applied when we are doing all this in the addition and subtraction of phases, right? So that's one thing. The other thing is that when we are adding phases, let's see, the other thing is that when we are subtracting phases, let's say we are trying to find let's say v1 sinusoidal, so at function of time, right? We're trying to subtract v2 from it. The principle says that you reverse this one. So by reversing that, we basically, if we're to be something of this sort, let's say v2 is this, right? So if you are reversing the meaning, we basically add 180 degrees, right? So if you add 180 to this, it becomes what? Plus 90 degrees, right? So that's basically what it says. All right, so when you're trying to add this, you basically just do this. It's just v1, right? And then you add this one, basically v2, this. Let me put a bracket here, and then you rotate by 180 degrees, right? So that's v2 rotated 180 degrees, right? So that's what it's saying. So we are going to look at this example and then solve this real quick, and then we move on. When it comes to addition of phases or subtraction of phases, basically we do vector addition, right? So basically these quantities are as a function of time, so they are not straightforward as in DC, right? So this is what we do. So for instance, now we've seen that we can only add up quantities that have the same frequency, right? And then when we are subtracting, we reverse the other one, the one we are subtracting, and then we do addition. Okay, so now we're just going to do the addition. When we look at these ones, for instance, let's say we are drawing them. If I'm trying to draw V1, you see that V1 has no shift in it. There's no shift. There's no plus or minus any other degree value here, right? So it's in phase is the general sine wave are working. So that will mean that if we are drawing a phasor for it, V1 will be something of this sort, right? It will be in line with the x-axis. So it's just straight like this. This is basically V1. And then if we are drawing V2, this V2, what does it do? Negative means lags, right? It lags V1 by 90 because they have the same frequency and everything, right? So V2 be about here, right? V2. So whenever you're adding phases and they are like this, it is very easy to add them up. Okay, so for this one, for instance, what we do is that, let's see, when both they are 90 degrees to each other, the adding is very easy. So what we do is that we said, so when we add, let's see, so when we add V1 and V2, right, the result that we'll get will also be a sinusoidal quantity, right? And we said that for sinusoidal quantities, they have a general form. So it was voted that we added, so we end up getting voted in the end. So the voted will be something like, let's say, V, right? And then we'll have the maximum quantity, and we'll have a sign, right? And then we'll have WT, and whether plus or minus, what do you call it? Theta, right? Whether there's a phase shift or not. It could be zero, it could be nothing at all, right? So here could be nothing at all, but I'll go through that one by one. Okay. So then when you're adding sinusoidal quantities, right, this V1 that we're trying to find here, how we find it is that before we even get to this one, you have to find the Vm, right? You have to find the Vm, and we know the addition of two sinusoidal quantities to be a sinusoidal quantity, so we'll maintain this. And then the only thing that will be different here is that we find this angle here, right? This theta here. We find the theta. So this is how we go about it. Here's a plus or minus. We don't know whether it will be 0 or there will be a value. So that's how we do it for this particular one. So because these quantities are actually 90 degrees to each other, when we are trying to find a VM, the vector quantity is very easy. So basically, in order to find this VM here, right, is so basically when we are saying that vectors, what we mean is that this VM squared here is equal to the peak, right? So v1 peak, right, squared plus v2 peak, right? So the peak that we are looking for as a result is like this. So then we end up getting a VM this way, square root of v1 peak squared, right, plus v2 peak squared, right? All right. So we know that when we add the v1 and v2 sinusoidal quantities, we have something like of this form, right? So we are going step by step to see how it is, and we know they are 90 degrees apart from each other, so it's like this, right? Okay. So we move on. Now we are doing this one step at a time. We are finding the VM, which is this one right here, right? Okay. And then this is how we are going about it. So then square root, right? The v1 is what? The v1, the peak of it is 60, right? Then again, this procedure only applies when the quantities they are adding up are 90 degrees to each other. That one is very straightforward. Look at another example. So the peak for the v1 is what? 60. Right, so we have 60 squared, and the peak for the v2 is what? 80. So then 80 squared, right? 80 squared. So that will give us this. So let's see. It's very important that we get to understand the basis. These sinusoidal quantities are vectors, right? Because we said that the Phasors simplify our work. And how do they do that? By giving us the magnitude of the RMS value of the sinusoidal quantity, right? And then the direction. So basically they are vectors. So that's why we are doing vector addition, right? Yeah. So that's the basis for how we are doing it. This why we are doing it this way. So 60 squared, t squared. So that gives us 100, right? So when we add them, the peak value for the resultant, right, it will be this V 100 volts, right? So yeah, so we found this VM here. So now we move on. So now that we found this, okay, let's do one small representation. We say we are adding vectors, right? We know this v1 here is a vector. This v1 here is a vector. This v2 here is a vector, right? And this thing that we are trying to find here, when we add them, it will be a resultant because we're adding vectors, so it will be somewhere about here, right? So if so, then mean that phase angle, this one here, relative to the v1 here, which is the reference that we are using, which is parallel to the x-axis, right? So that this will be something like a triangle, right? Yeah, triangle. Then we can do trigonometry. So now we found the VM. We know the sign is still will be there. This WT, they are both having the same frequency, so we won't change anything. The next thing to do is that we have to find this theta here, right? Whether it's a plus or minus, we don't know. We'll have to do that later. Okay, we'll get to that. So then, now that we know the VM, we move on to the theta. The theta is done this way. It is clear that this V2 can appear by here, right? And then we get some kind of like triangle here, and this is the angle that we have here, right? So this angle you can find it using what do you call it? The tan, right? So we know tan theta to be what? Opposite over adjacent, right? Right, and then opposite in this case is the what? The v2, right? So v2 function of time, no, just the peak quantity. This case just the peak. Okay, so let's just write this v2 peak all over what? v1 peak, right? So that's the tan theta. So if you're trying to find theta, that'll be tan inverse of what? v2 peak is 80, right? And then v1 peak was 60. Okay, so let's see what we have for this. We have 80, and then we have what? 60, right? 53. So that's 53.13. Let's do 4 dB. 01 degrees, right? Okay, but then let's look at this again. Here we found the theta, but we don't know whether it's plus or minus. And how do we go about that? Clearly, looking at the diagram here, we know the v1 as this way, the v2 is this way, the resultant can be the resultant can lead this one is the reference, the v1 is the reference. So as how they are appearing here, the resultant, which is this one here, let's just write something. Let's see, v resultant, right? This one here, it cannot lead the v1, right? So then it will lag it, because it will have to move in anti-clockwise direction to go and meet the the v1. So as a result, it will be, what do you call it, it should be it's lagging, right? It's lagging the v1. So we want it to be where it is now. We want it to be where it is. So if it's lagging, then it's minus, right? So as a result, we end up getting a minus. So the v1 that the resultant, so what, sorry, the v1, right, plus the v2 that we are finding will give us this, which is the v that we found. That will be we found the peak already. The peak is 100, so we have 100, right? It's still a sine wave, sine, right? And then we have a wt, which is still there because their frequencies are the same. And then we said this quantity v here, was it this v here, because of how the two ones are, it will end up lagging the v1, right? So to be lagging, so if it's lagging, negative, right? So then we have a negative here, and the angle by which is lagging is this 53.13 degrees, right? But there are times where these degrees are written in what's the name, radians, right? So you could have it in radians, you could have it in anyway in a lot of form, right? But in this particular case, we are keeping it in degrees, right? In degrees. Well, let's see if we can 180 is pi, right? So 180 is pi, so then this 53, what's the answer? So this 53.13, what will it give us? 3 will be less, so more divide, so 53.13 on 180, so that this will be the value. So it will be this one right here is kind of like equivalent to 0.2951 pi, right? So by here we are keeping it in degrees. We are keeping it in degrees. What we do this time around is that we are subtracting them, right? So when it comes to the addition or subtraction, what it says is that for the subtraction, it says that they must be of the same frequency. So we've checked, we've seen that the frequencies are the same, right? When it comes to subtraction, it says that the one that you're subtracting from the other, you reverse it. So now let's try and write this out first, and then we'll look at what's happening. So the v1 is something of this sort. There's no phase angle here, so it's in line with the x-axis like this, right? And this one here is lagging the first one by 90, so it's like this, right? So what the subtraction says is, so this is v2. What the subtraction says is that when you're subtracting, what you do is that you reverse the second one. This is the second one. So by reversing it, basically you're adding what, 180 degrees to it, right? And when we add 180 degrees, so let's see, when we add 180 degrees, this one goes away, right? We end up getting what, 90 degrees to the reference, which is still this one. So basically this one, this is how it turns out this way. So let's see, okay, the principles are quite straightforward. When you understand that, you'll be very good to go. So then again, this is the example where we are adding phases that have the same frequency. You should take note of this. One's a bit straightforward, but then if you understand addition of vectors, when you get to the other one, you see that it's still the same thing. Quite easy and straightforward as well, the moment you understand the principle from this one. So now we've reversed it. So basically this is no longer v2, but it is what, negative v2, showing that we've reversed it, right? So we said that when you reverse it, you end up getting when we are, it will be something like this, v1 t, right? And then we have plus, when we reverse it, then we get minus v2, right? Function of time again. So that's how it has become now, right? So by adding a 180 with by reversing it, we've transformed the whole thing to this way, but still the same thing, right? We're just adding. Okay, so now this is what we have. So this is no more minus 90, but it's what, plus 90 now, right? So now it's plus 90 degrees. Okay, so now it's clear. Since they are 90 degrees to each other, we just do, so then again we said for sinusoidal quantities you have a general form. One of them is v, let's say that's small v, so we have vm, the peak, and we have sine because they are sine waves, right? And then we have wt, right? And then we have plus or minus theta depending on the phase shift, right? Or the phase angle, right? Okay, so now because they are 90 degrees to each other, we are going to find out very easy to do. So basically the vm that we are looking for here will be square root of the RMS, the peak of v1, so v1 peak squared plus what, v2 peak squared, which we have found earlier, right? So let's see, to be the same thing, so that'll be 100, right? So we have this one to be 100, right, volts, right? The next thing to do is that find angle. Right, but let's go over it one more time. That's v1 peak was 60 s60, right? So 60 squared. v2 peak is 80, so 80 squared, right? Sometimes at times the values of this can be negative, so you have to write them clear, put them in brackets so it's easier and you get the basic concept so you can apply them everywhere. So that gives us 100, but let's confirm. Squared, yeah, so that gives us 100. That we have written already. Okay, so now that we have this, the next thing will be, so there's a general form. We found the vm, we found the peak value, right? We found this. Then we know it's a sine wave. The addition of sine waves will be a sine wave, right? The next thing will be to find the phase difference or the phase angle, right? So let's see. To do that, still the tan, but then let's look at this very well. Now that we've, so this v2, this v1 here is still the same. It remains at this position, right? The v2 here has been transformed, is negative here, right? And now it's like this. So basically that what we mean is that our resultant to be here, right? And then the angle that we are looking for will be reference to this axis here, the x-axis, or the v1, right, will be here, right? So what does it tell you? This will tell us that basically the v that we are looking for, which is this right here, let's say vr, this vr that we are looking for, what will lead the v1 by theta, right? So now we'll go forward. So to find the theta, as we've said, theta is what, tan inverse of looking at it very well. So we have a small triangle here, right? So opposite will be v2, right? v2, so v2, right? v2 peak on v1 peak, right? So what do we have? So that's tan inverse v1 peak, sorry, v2 peak is 80, v1 peak is 60, right? I think it will give us the 53.1 something. So that's tan inverse, and then we have 80 on 60, yeah. So that gives us 53.13, let's do 40p 01 degrees. So this is what we have. All right, so now we have everything. So when we are trying, so basically we started with this. So we said v1 t, function of time, minus v2 function of time is the same as v1. We reverse the second one, right? So vt, and then we have plug, and we do a plug like this. So let's put this in brackets. This is something else, right? Okay, and then v2 negative because we reverse it, t, right? And this. So this is what it will give us, right? So we found the vm, which is the peak for the resultant, which is 100. So 100, and the sum will still be a sine wave. They are both having the same frequency, so this, right? But then we've seen clearly that the v resultant will lead the v1, right? By how many degrees? 53. This w, it looks like 10 t. Angular momentum, angular frequency, and period, right? So it's a leading. The resultant is leading, so plus, very important, plus, and then we add the phase difference, right, which is 53.1301 degrees. it could be about 100, about 53. Right, so plus 53 degrees, right? Yeah. So that's it. Adding this is the very direct one where the faces are 90 degrees away from each other, right? The adding and subtraction. So we'll be looking at another example that's a bit complex. That we add different faces, different frequencies. All right.